Welcome to Decoding the Future, the podcast where we dive deep into technological innovations that are shaping our world. I'm Mahesh Krishnan, Chief Technology Officer for EP.3, based in Australia. And today we're going to continue our exploration of artificial intelligence, AI. This time we're going to focus on Vision AI. It's a fascinating technology that's transforming how machines perceive and interpret visual information. In our previous episodes, we unpacked the incredible world of GenAI, and now we're going to zoom in on Vision AI. This is basically a field that's pushing the boundaries of what machines can see and understand. Joining me today is an expert in this area, Professor Amin Beheshti. Together, we'll unravel the complexities, potential, and the profound implications of Vision AI in our rapidly evolving digital landscape. First, welcome to the podcast, Amin.
Thank you, Mahesh.
Introduce yourself.
Thank you, Mahesh. My name is Amin Beheshti. I'm a full professor of data science and AI at Macquarie University, Sydney, Australia. I'm also adjunct professor in University of New South Wales. I'm the founder and director for Center for Applied Artificial Intelligence and the Data Science Lab at Macquarie University.
By the way, Professor Amin was also the winner of the AI Academic Researcher of the Year recently. So congrats on that award as well.
Thank you so much. Thank you so much. It happened on the 6th of November. It was.
All right, let's keep digging off on the question. So, as you teach AI within the university, can you give us a bit of a textbook definition of AI, if you please?
Yes. So, I'm teaching courses like machine learning, AI, and the first thing that I start introducing this concept to students. I start explaining what is intelligence. Because we are intelligent entities as humans, and intelligence defined as the capability to acquire and apply knowledge and skills to accomplish a process. So this is intelligence, and we are really lucky as humans to have this gift. So there are a few important components in the definition of intelligence. So the first one is knowledge. So we are acquiring and applying knowledge and skills. So knowledge one is where, as humans, we have the education system. We train our kids in kindergarten, in primary schools, feed them, with lots of knowledge. It's like, training intelligence machine to understand, what's happening around the world, what are the main entities around us. So those type of knowledge. And in cognitive science, we call this analytical intelligence. So analytical intelligence, will help us identify entities, around us, and identify faces, anything that we see, we have an explanation for that. Then the skill part of intelligence, knowledge and skill. So the skill part is specifically something that, we learn from subject matter experts over time. That's why in high school and bachelor degree in universities, we try to train the next generation based on some domain-specific knowledge. For example, someone wants to be a medical doctor, someone wants to be a lawyer, someone wants to be an engineer. So there's a new language there, that they are learning, lots of new concepts. But, the main important thing, that they will focus and develop is the cognitive and applied intelligence. So, they will learn how to choose the best next step and decision making. And then if we go back again to the definition of intelligence, acquiring and applying knowledge and skill is the most important part. And in psychology and cognitive science, that relates to generative intelligence. So which is where, when we understand the knowledge, when we understand the skill sets and best practices, we are ready to generate new content, new way of doing things and stuff. So most of the innovation comes from generative intelligence that we have. If we look at, over time, all the innovations that we have, there will be a training and education system. People get to some points to be able to create something new. For example, the car, the jet engine, in digital area, we had the computers. So generative intelligence is very important, and it's really interesting to know that in universities, we have research degrees specifically to teach the next generation how to be creative, understand problem-solving skills. And all these things and stuff are designed to help us accomplish a process. So you have three main types of intelligence: analytical intelligence, cognitive intelligence, and generative intelligence. Okay. Then we use these, to accomplish a process. So process is everything for us as humans. So again, going back to the definition of intelligence, intelligence is a gift and it helps us acquire and apply knowledge and skills to accomplish a process, right? And then over time, we human came to the point that we were able to generate intelligence, in an artificial mode. So this is what we call artificial intelligence. So simply, artificial intelligence could be defined as designing any system or algorithm that is intelligent. What does it mean? Any algorithm or system, that is able to acquire and apply knowledge and skills to accomplish a process, could be considered as artificial intelligence. So this is where we have different AI systems: analytical AI, cognitive AI, and generative AI.
Okay, no, thanks for the explanation. Now, speaking of Gen AI, generative AI, right?
Yeah.
We got mentioned that it's just been 2 years since ChatGPT was first released to the public. I think it was like November 30th, 2022 to be precise. Now, in your view, do you think that Gen AI has basically transformed the industry much into Gen AI as a whole? Yeah.
Yeah. So as I mentioned, generative AI is any AI system that can generate a new content, new process, or a new anything. So it can be a 3D model of something, right?
Yeah.
And it already started transforming businesses because, as we discussed, the business process is heart of any organization, right? And if there's an AI system that can generate new process models or process instances or help knowledge workers in accomplishing the process in the daily activities, then this is something that, transforming the business. If we just think about the definition of a job, let's say, for example, when a company recruiting a person, there's a job description. And if we carefully looking at the job description, we see a set of, daily processes, weekly processes, quarterly processes, and, yearly processes that need to be followed to, let's say, complete, the tasks in the company. If we just look at jobs from process point of view, and then let's say there's a Gen AI system that can automate, augment, or improve those processes, that could be a transformative technology. Just think about, there are lots of jobs, and, during most of the jobs, we need to write emails. And, before ChatGPT or, similar technologies, we took lots of time and effort, in generating a very good quality, respectful email, for example. But now, you save lots of time. So, for example, you can just, give a draft to a Gen AI system, and it helps you, save time preparing a draft for your email or customize or personalize it, right? In education, for example, we have been observing our students, they use Gen AI to receive feedback, before assessment tasks. And we have seen that, it helped a lot, to improve the quality of teaching and learning for our students. In banks, we see, there are lots of Gen AI systems, used to generate synthetic data to better understand, the customer journey and the whole customer life cycle processes. There are lots of, Gen AI systems used to, for example, improve processes in healthcare, for example, in identifying disease or, for example, predicting them. So it already started to transform the processes that we have in different sectors, from health to education to banking.
Okay, that's good. Look, one of the previous episodes, we took a deep dive into Gen AI and basically examining the landscape from both the consumer as well as from an enterprise perspective. And there's something fascinating that we uncovered, right? Despite the incredible technological revolution that's happening around us, we discussed that the adoption of Gen AI has been surprisingly measured, right? I mean, some more companies are moving at a breakneck speed, while others are being very, very cautious. Now, consider this, we're witnessing an extraordinary phenomenon where new foundation models, AI foundation models are being released almost every 2.5 days. And that's an incredible pace of development, right? Yet we felt that the real world implementation, at least in the enterprise adoption space, has been a little bit much slower, right? Anyway, today we're shifting our focus to an equally exciting domain. We want to talk a little bit about Vision AI. And Fujitsu and Macquarie have been doing some fascinating joint research in this area. But for our listeners who might be new to this technology, let me break down Vision AI. At its core, it's about teaching machines to see and understand visual information in a way that's similar to human perception, but with almost like a superhuman precision and speed, right? Imagine an AI system that can recognize objects and people and everything else in an image or a video but understand context, interpret complex scenes, detect subtle changes, and even predict potential outcomes and so on. So that's basically what Vision AI is all about. So it's not just about capturing images, it's about like comprehending them as well. So I mean, let's take a little like a deep dive into this topic, right? Can you help our listeners understand like the fundamental principles, some of the real world applications, and maybe maybe even some of the challenges and opportunities of Vision AI?
Yeah, of course. So as you highlighted, Vision AI, refers to the application of artificial intelligence to understand, interpret, and analyze visual data, such as, image and videos, right? So just consider you have an AI system. When you, provide an image, to this AI system, it explains everything to you in natural language statement. So you can easily interact with the data. For example, you have a photo of, Harbor Bridge and Opera House, and then upload it into the system and ask the system, hey, explain this photo to me. It tells you there is for example, Opera House built in this, for example, point in time, located in Sydney, Australia. Next to that, you can see, let's say, Harbor Bridge. Then you can also interact with the system to get more information, from the system. So Vision AI, could cover all these things and stuff. And more importantly, key components for Vision AI include image processing, for example, some techniques like, filtering or edge detection, to analyze images. Other techniques include object detection and recognition. So for example, you want to identify a person or an animal. There are lots of semantic segmentation involved, for example, for labeling, the images. For example, you want to identify different parts of an organ in a medical scan. So the semantic segmentation, has a very good application there. Facial recognition, you mentioned. Activity recognition, for example, Fujitsu has this actualizer technology that interpret actions, in a video, for example, such as recognizing the gestures or activities in, surveillance footage. Anomaly detection, could be another interesting one. For example, there's a big factory, and then you want to detect, defects, in the manufacturing, right?
Yeah, absolutely. Yeah.
So if we just think about applications in Vision AI, the most easy low-hanging fruit that we see, and, it's, we see that every day, is just, autonomous vehicles, just enabling self-driving cars, to detect road signs, pedestrians, and other vehicles. In healthcare, for example, we use Vision AI to analyze medical images like X-rays, MRIs. It is a big, advancement in diagnosis and, predicting the disease. In retail, just think about it, enhancing customer experience, through facial recognition or, object recognition. In manufacturing, we can focus on the quality control, by, as I mentioned, by, detecting the defects in the products. Security and surveillance, just think about, smart airports when everything, any threat or security issue, could be detected in real time. For example, in terrorism activities, as a simple example. More in agriculture, for example, monitoring, crop health through aerial drone. There will be drones, taking, video footage and image footage, of the products, and it will help us, identify pests or, for example, diseases in plants. And also the AR and VR, in entertainment, the huge opportunities there. But as highlighted, there are lots of challenges and also, good opportunities for Vision AI. The main challenge, that we can discuss, and always, when we discuss about AI systems, it doesn't matter it's a Vision AI or, AI system that help us understand textual data, for example. There are lots of data challenges. So data quality, is a big deal. For example, Vision AI requires large amount of, high quality labeled data. Collecting and annotating such data sets, are really time consuming. But the good news is that, for example, back in 2021, the researchers in Stanford introduced, new models, foundation models, that they can focus on unstructured data in unsupervised manner. So you really don't need, much labeled data. But if you want to train the model for some domain-specific applications, you have the options for tuning if you have some labeled data. If you don't have labeled data, there are options for prompting. For example, prompt engineering is a big topic by itself. So going back to the challenges for Vision AI, data diversity is another challenge in Vision AI. So there are different data sets, diverse conditions, different environments. Privacy concern is another thing. So you are not easily have access, to all, the private and secure data. And if you train your models on those type of data, there are lots of challenges.
I mean, you did mention facial recognition at one point, and then doing that is also a bit of a problem, right? I mean,
exactly, yeah. Just think about, for example, in some countries, if you want to take for example, some images or videos, of the face of some, citizens while, they are walking in the street or getting into the shop, there should be ethical approval to do that. So it's not like, for example, even if we want to, let's say, do research on animals and we want to take a photo of a bird on the campus, we need to have ethical approval for that. But some countries, they are easygoing, on those type, but in some countries, they have more specific regulation.
Yeah.
The other challenge that I can think about is computational complexity. So Vision AI, is more high resource demand. So training and deploying Vision AI models most of the time require significant computational resources, and it's expensive, of course. So if you want to use cloud services or GPU servers, there are lots of investment on AI infrastructure that need to be done.
Yes.
Specifically, if you need to have real-time processing needs, for example, autonomous cars, or for example, if you use that in defense or in policing, real-time processing is quite important. Scalability, is another thing that we need to consider. Deploying Vision AI solutions at a scale, specifically on edge devices, could be challenging. And the main issue is, hardware constraint, for example. Ethical and social concerns, all around of any AI system. It's not just limited to the Vision AI. We have issues around, bias, discriminations, for example, misuse of deep fakes. Just think about this, deep fake Vision AI technologies like GANs. They can be exploited, for generating misleading or harmful content. So lots of interesting topics that we can think about. But Mahesh, I remember Fujitsu has done some projects using Vision AI, right? So what challenges, have you come across?
Well, Fujitsu do some really fascinating stuff using Vision AI. I mean, one of the examples that I talk about a lot is a system called JSS, or Jet Support System. So we use it in World Gymnastics Championship and Olympics and things like that. So we basically slap, when a gymnast is performing, right, we slap a skeletal model on the person. And when the gymnast performs a routine, like a complex routine, right, like a backward double sort or single twist or something, whatever they call them, right? So we are able to use the cameras to precisely measure like the angles of like how much they've bent their elbow, for example, or how much their foot has gone over their head and everything else, right? So this is like a very completely, it's very completely objective, and it provides like very precise scoring that can actually help the judge. But from a commercial application, right, one of the things that you actually mentioned was around, aggressive behavior in public place and things like that. We recently completed one, and again, we put a skeletal model on people in the area, right, and then look for actions. There are a number of challenges that we did look at. I mean, one of the things was around things like lighting. So when you test things in a lab environment, right, we have like really good lighting and everything else, and suddenly you put it in a public space where you have lots of sunlight coming through during the daylight, and then you have some really dark shadows falling on some areas, making it difficult to interpret, right? It's all vision in a way, right? And you have people wearing dark clothing, for example, standing in the shade. It's almost sometimes difficult to interpret whether someone's standing there. We also found that things like positioning of the camera, like the resolution of the camera, all that is quite important as well. Fixed camera for us was really important where it's set up, and wide angle camera is another one that we actually found. Is like when you have like wide angle camera, the end of the edges of the camera, right, you start to appear like a slant, and we call it like barrel distortion, and then you looks like after the person is on a side and then, they're almost falling down sometimes, right? So the AI sometimes misinterprets some of those things. And things like, 360-degree cameras, fisheye cameras, because of that, it was a problem. But one of the things, right, I said camera positioning, occlusion is a problem. If you don't place the cameras in the right place, when you have multiple cameras and multiple people walking in a public place, one person gets on, covers the other person, or, they stand behind a pillar and things like that. And then when you have a skeletal model, it becomes really difficult to interpret it. What else did we have? I think, we have, this is in a bus, right? In a public place. So you had buses and everything, vehicles going around. And then these buses had images of people in there. And then it starts to detect these people and think that they're actually doing something and say, hey, look, they're not supposed to be in this area or of interest that we actually crossing and things like that. Look, we did have a wide range of false positives, particularly, things like fighting and things like that, and someone engaging in a fight, they don't follow any rules. So we have like huge class imbalance. It's not always people throwing a punch or kicking or whatever, right? It's just random, people pushing, shoving, and all that kind of stuff. So creating is a bit of a difficult in those scenarios. So, we had to we have a large number of false positives, and we had to have this precision recall paid off and things like that. So
That's great. And how did you address some of the issues that you highlighted?
yeah, look, I think that's the main thing, right? I mean, like we went back and did tried to reduce some of the false positives, more training and things like that. But the GenAI was the main thing, right? When we detected an event, right, that skeletal model basically detected a punch or something like that, right? And so punch is an easy thing. When people pull up their mobile phone, it almost looks like someone is actually doing a punch. So you basically look at it and say, hey, look, this is detected a punch. You pass it through GenAI and say, look, can you validate this image and say what is the actually that's going on? And by that way, we were able to detect that, hey, look, that is not really a punch. It's just someone holding a mobile phone in their hand. There's nobody nearby. And that helped us dramatically reduce the number of false positives that we had. So
Wonderful. That's really interesting to see. Fujitsu has lots of interesting applications in Vision AI, and then how smartly you manage lots of challenges there.
So before we wrap up this episode, what advice would you give aspiring professionals in this field of AI?
Yeah, so there could be lots of advices for different levels of people with different levels of literacy. So there could be advices for general public, for subject matter experts in different fields, and professionals in AI domain. But what I see, what we have been observing, the nature of the work is changing quite quickly. And we have been observing that people who have been using artificial intelligence, in solving problems, in completing, their daily processes, they have been more creative. They could save lots of time. They could focus, on more tasks and stuff. So, this is the saying that, in future, people who are not using AI technology in their, daily work and processes will be replaced, with people who are using those technologies. Most of the people, they are pretty sure that, AI will not replace jobs, but people who are using AI, will replace people who are not. So for professionals in the field, so for people who are interested, in the field of artificial intelligence and data science, the most important thing is to understand the foundations and fundamental models. It is very interesting that, in AI, most of these advances, comes from software engineering. I give you a simple example. Traditionally, software engineering and coding, was the core of, all these tasks and activities. We had the computer, you program, and then there was an input, for the program. You pass it to the computer, and the computer, as a, let's say, processing unit, generate the output for you. But then, we had this machine learning, innovation and technologies where, we had the same computer processing unit, but there were no programs. So, there were models that could learn from some examples of the output, and then, feeding them, with the data, those models were able to generate the programs. And then if you connect, this program to the traditional software engineering model, so this is what we call machine learning engineering. So machine learning engineers, there are software engineers who upskilled to train models, generate programs, using machine learning technology. And then in the age of generative AI, we have the same processing units, and you really don't need to have the program, or you don't really need to have the input data. The only thing that you need to have is to have a high-level understanding of the problem. So then discuss with the system can generate the program for you, the system can generate the data for you. And, we have been observing in lots of markets, professionals started using these GenAI technologies to generate data, to generate program. And the future is like that. For example, you have a person who doesn't have computer science background, with a simple conversation with a AI agent, they are able to generate a complete, system and program. So there are lots of code behind in the system. For professionals in AI, it is very important to understand software engineering, data, AI models, machine learning models, to be able to develop the code, in the background. But for people in front, knowledge workers and SMEs, they should learn how to use this type of technologies.
Yeah,
that's why it is very important to invest on AI literacy. So I've been observing that some countries started to put budget in the government to train their citizens to be ready for the new wave of technology change.
It's a great advice. I mean, thank you so much for being here today and sharing your incredible insights into Vision AI. I think you kind of helps them understand some of the technical intricacies and nuances with this kind of transformative technology. So as we wrap up this episode of Decoding the Future, I'm also struck by how Vision AI is not just about machine seeing things, but also expanding our own vision of what's possible in this field. To our listeners, thank you for joining us on this journey of discovery. If you enjoyed this episode, please don't forget to subscribe, rate, and share Decoding the Future with anyone curious about these technologies that are reshaping our world. Until next time, I'm Mahesh Krishnan, and this is Decoding the Future. Thanks, Amin.
Thank you, Mahesh.